variance and standard deviation. We have already seen that measures of central tendency, mean, median, and mode provide information on the data values at the center of the data set. Measures of spread, quartiles, percentiles, ranges, provide information on the spread of the data around the center because they are all connected to the median as the measure of central tendency. The disadvantage of using these measures of spread is that they are quite insensitive to changes in the lower and upper quarters of the data. Therefore, it would be helpful if we could have a measure of spread that used all of the data values in its calculation. In this video, we will look at two more measures of spread called the variance and the standard deviation. These measures of the spread of data are connected with the mean value. Thanks for watching this video and don't forget to like, subscribe to the channel and activate the notifications. It's very important to the continuity of this channel. The variance is a measure of spread of values around the mean of a data set. The formula for variance is given by sigma squared is variance, sigma the sum of n number of data, x bar mean average of data, x sub k each of the values in the data, x sub k minus x bar the deviation of a data value x sub k from the mean x bar. The standard deviation sigma is simply the square root of the variance. Let's start with a very simple example. Find the variance and standard deviation for the following data. It's often useful to set your data out in a table so that you can apply the formula easily. To calculate the variance of a set of data, follow the steps. Calculate the mean by finding the sum of the values and dividing it by the number of values. Next, subtract the mean from each data. This value is the deviation of each data from the mean. We should notice that some of these deviations are positive and some are negative. If we try to calculate an average deviation using these results, the negative deviations will cancel out the positive deviations. To correct this problem, one method is to square the deviations. Squaring makes each term positive so that values above the mean do not cancel values below the mean. Next, square each deviation. Now, divide the sum of the squared deviations by the number of values in the set to get the variance. One problem with the variance is that it does not have the same unit of measure as the original data. For example, original data containing lengths measured in centimeters has a variance measured in square centimeter. Since the variance is squared, it's not directly comparable with the mean or the data themselves. So the standard deviation is the measure most commonly used to describe a measure of dispersion because the standard deviation is the square root of the variance, so that it returns to the original units of measure of the data set. Finally, take the square root to get the standard deviation. The point of the previous example is to familiarize you with the process of computing standard deviation. The standard deviation shows how much variation there is from the mean, and it represents a typical deviation from the mean. Standard deviation is only used to measure spread or dispersion around the mean of a data set. Low standard deviation shows that the data points tend to be very close to the mean. High standard deviation indicates that the data is spread out over a large range of values. The next example is more interesting. Pay attention. Two runners, A and B, compete for a spot to represent their country at an Olympics. The two runners in the 200 meters race clocked times in seconds as follows. In case of a tie in the average of the times, the tiebreaker would be in favor of the most regular athlete. Which athlete will represent their country? To start, display our set of data out in a table. Calculate the mean. We should notice that the mean is the same for both runners. Standard deviation is the measure of spread most commonly used in statistical practice when the mean is used to calculate central tendency, and it is useful when comparing the spread of two separate data sets that have approximately the same mean, as this example. Therefore, the athlete with the smaller standard deviation is more regular. Subtract the mean from each observation. Square each of the deviations. Add these squared results together. Divide this total by the number of observations. This gives the variance. Take the square root to get the standard deviation. Do the same for runner B. The athlete A will represent their country because he has the lower standard deviation, so he is the most regular. The following table shows a frequency distribution of daily number of car accidents at a particular crossroad during a month of April. Calculate the standard deviation of the number of car accidents. The formula for variance and mean changes slightly if observations are grouped into a frequency table. Squared deviations are multiplied by each frequency's value, and then the total of these results is calculated. Let's see how it works. The formula used to calculate the mean and variance for grouped data are as follows. The frequency table can be extended as follows. We now perform the calculations as we did before.